Hello, my name is Isabella Gonzalez and I will be going over my midterm for BME4503. So for this midterm, I created a GUI using the MATLAB app designer, and what I basically did was that I took voltage readings and I converted those into temperature values in degrees Celsius, and then I displayed and plotted the change in those temperature values with respect to time in seconds. So before I go over my GUI and its features, I will be going over my Arduino and circuit setup. So this is my Arduino and circuit setup. So this is my Arduino board, which is an Arduino Leonardo, and it's connected to my computer using a micro USB cable. And it is also connected to this breadboard using some jumper wires. So for my breadboard, I have the first thing that I have is this LM335 temperature sensor here. So this temperature sensor has 3 pins. The first pin here is the adjustable pin, which is used to calibrate the sensor. So in this case, it wasn't necessary and nothing is connected to it. This second pin is connected to this orange jumper wire that connects to the analog pin A0 from the Arduino, and it is also connected to these two resistors of 1 kilo ohm each, and these two resistors are in series, and then connected to this orange jumper wire that goes to the 5 voltage pin from the Arduino. The third pin in my temperature sensor connects to this white jumper wire that goes to the ground in the Arduino, and then this jumper wire that goes to the blue LED diode here. So the blue LED diode is also connected to this 1 kilo ohm resistor, and that's gonna basically control the current that is passing through the diode, and it's also going to prevent the diode from burning out. So this resistor connected here is also connected to this jumper wire that it's going to connect directly to the digital pin 11 or D11 in the MATLAB code. So that's it for my circuit setup, and now I will be going over my GUI. So now I will be going over my app designer code. So this is the design view of my GUI. So as you can see, the first thing that I have is the axes. So this is the plot for temperature in degrees Celsius versus time in seconds. Now here I have 3 buttons. I have the start button that basically starts the while loop. I have the stop button here, which basically stops the while loop, and when it's pressed, it also provides the average temperature of all the temperature values that were collected. And here I have the clear button that basically clears the axes and these values that were recorded. And here I have 2 GUI LEDs. The first one, the high temperature alert, is gonna be mustard yellow whenever we're below the threshold of 22 degrees Celsius, and then once we reach those 22 degrees Celsius, it's gonna be red. And the active LED, this is gonna be white whenever data is not being collected, but once we press it and data is being actively collected, this is gonna turn red, and when we stop it with the stop button, it's gonna go back to white. Now these 2 boxes I created with the edit field numeric option. So this first one, the current temperature in degrees Celsius, is gonna give the live temperature values, and they're going to change as data is being recorded. And then The average temperature basically gives the mean of all the temperature values that were collected, and this is gonna change, and this is only gonna be provided once we stop the data recollection. So that's it for the design view. Now I'm gonna go over the code. So since this is app designer, I had to click on properties and basically create some variables that act as global variables. So I created A for the Arduino, these two are for the stop conditions, L for the animated line, T for time, N for the count or the number of iterations. And these three variables are to save the variables into arrays. So the first function that I have is the startup function. So for the startup function, I basically have this first one is the A for the Arduino. So using the Arduino function, I was able to make that connection with the Arduino. And this is the USB port that I'm using, and this is the board that I have, which is the Leonardo one. And then with the animated line function, I basically created this animated line and I assignated it to the UI axis. And here I specify the properties for that line. So I wanted it to have a straight line and some markers. So for each point, we're gonna see a circle, and I activated the grids. Then I created a stop condition here, which is later on gonna change for the while loop. And here using the callbacks, I was able to create functions that are gonna specify what each button does. So the first one that I created was the one for the stop button. So here I basically changed the stop condition so that I could stop the while loop. And in here, I'm changing the conditions for the active LED. So the active LED is going to be red whenever the data is being collected, and then it's going to go back to white whenever data is not being collected. So what I did here is basically, since this is for the stop button and data is no longer going to be collected, I just said that the color is now going to be 111, which is the MATLAB code for white. And then here I just created the average. So in here I created an index so that I could index all the temperature values that were collected and save them all in an array, and then I took the mean of that. And in here with this function, I basically just assign that value of the average into the box for average temperature in Celsius. So this is the callback function for the clear button. So basically with the claw function, I just clear the axes. Here I just clear the points, and here I just set the previously obtained values to 0. And this is the start button function. So the first thing that I did here is that I created a time variable and I set it to 0 for the start, and then I created a count for the iterations, which is n. And then I created my while loop. So this is just saying while this doesn't equal the stop, or while the stop is not being reached, all of the following conditions will happen. So the first thing that I did was I took the voltage readings and I assigned them to a variable B, and then all of those voltage readings were converted into a temperature in Kelvin, and this is from the ratio that is provided in the datasheet of the LM335 temperature sensor. From there, I converted those temperatures in Kelvin to Celsius using this conversion, and then I saved all of those values into different arrays. Then the add points function basically just adds points to the animated line. So I did that using the obtained values for time and temperature in Celsius, and then I displayed the values from time and temperature into the command window so that I can later save them as results. And then I used the function draw now so that I can plot the temperature and time in real time. So that's gonna start the plot, and then the temperature values that were obtained are assignated to the current temperature box, and that's from the edit field numeric option in the GUI. And now here I start creating some conditions for the LEDs in the GUI. So in here I create a condition for the active LED. So this is just saying when the data is being sampled, the LED will be red. So I'm assigning red here. And then here I created the conditions for the high temperature LED. So when the temperature is below 22 degrees Celsius, it will be mustard yellow, and the MATLAB code for the mustard yellow color is here. And then when the temperature of 22 degrees Celsius is reached, this LED will change color into red. So this is the code for red. And then now I started to create the conditions for the physical LED, the blue LED diode in the breadboard. So now when that same threshold of 22 degrees Celsius is reached, the physical LED will be turned on. So this is how I turned it on, just using the write digital pin function. And here I had to specify that it is connected to the digital pin 11, which I show you in the breadboard. And the second condition is that whenever it's just below that threshold, this is not gonna take any voltage and it's gonna be off. Now, one of the requirements for the midterm was that we needed to have a sampling rate of 2 samples per second, and to achieve that, I created a pause of 0.5, and then I also did increments of 0.5 for the time, so that that could be visualized in the plot. So that's why I have those things, so that I can obtain 2 samples for each second. So we're gonna see in the plot that we have 2 points for each second that we see. And here I just increase the count, and that would be used for indexing. And here I change the stop condition so that the while loop can be stopped. So that's it for my code. Now I will be running the experiment. Okay, so now I will be going over my experiment. So I'm just gonna press run. And the GUI pops up. So now I will be pressing start. So for the first 30 seconds, we're just gonna see the values for room temperature. And then at 30 seconds, I will touch the sensor to see any changes. So now we're at 30 and I'm touching it. So we can see that at 22, it turns on. I'm still touching it. Also, we can see that when it turns on, the high temperature alert goes red. Okay, so now I'm gonna stop touching it. So now it goes back to a normal and stable temperature reading. And since we are below the 22 degrees Celsius, the high temperature alert went back to the mustard yellow, but the active LED is still on red. And I will stop the data recollection at 120. Okay, so that's it. Okay, so now the last thing that I'm gonna do is show that the clear button works. So here we have the GUI with the results, and once we stopped it, we can see that the average temperature recorded is 22.06, and we can also see that once it was stopped, the active LED went back to white. So that's it for the results, and now I'm just going to show you that the clear button works. So once we press it, we should clear all the data, and that's it. So we can see the clear axes and clear boxes. So that's it for the GUI and for the midterm. Thank you.